Okay guys, welcome back to the SSAS and MDX training sessions, class 4. So in last session we created a dimension with the name customer, and before that we discussed about how to identify the dimension tables and the fact tables, right? Now it's a small recap. So um, any metrics will fall into measures. I told you, measure groups or measures, and any textual data that is required for your analysis, 90% or not any, 90% of the textual data or the table that has textual information will fall into your dimension category. And you all know that fact table is treated as a measure group, whereas a dimension table is treated as a dimension. And column in the dimension is treated as an attribute. We call the term is attribute, ATTRIBUT. Similarly, the column in the measure group table or fact table or any metric, we call it as measure. So we'll be talking about these four terms a lot in next few sessions. The four terms are measure groups, dimensions, attributes, and measures. So in this session, we will be concentrating on dimensions and attributes. So the columns of a dimension table, which is used for your analysis purpose, will be created as a we'll create them attributes out of those columns. Now, if you see the example here, I just added all the columns, or I picked 4 or 5 columns from the dimension table. So all those columns are attributes. Bill to customer is an attribute. I want to see the sales by bill to customer, and I want to see the sales by buying group. What group has more sales and what group has less sales. Similarly, category is a column, right? Column will become an attribute here. And attribute, every column will have data, right? Every column data, we call it as members of the attribute. So this is an attribute. An attribute will have multiple members. So if I go back to the diagram again, so a dimension is nothing but an object or a table. This will have one or many attributes, and each attribute will have one or many members. Members means nothing but the column values. Like for example, if this dimension is location, and if this attribute is country, the members will be India, US, Pakistan, Bangladesh, and so on. Similarly, if this is city, there will be the attributes will be Hyderabad, Bangalore, JC City, and so on. So the column values are called as members in the attributes in SSAS terms. Now, I created a dimension. How can I see the data? So the ultimate goal, as I mentioned, the output of an SSAS project is again a database. How can I see this database? How can I see what data is coming through this dimension that I've created now? So to see the data, you need to deploy it, or you need to deploy and process the cube. Processing is, we will discuss about processing. So you need to deploy and process the cube. So if you go to the cube, properties, you see a few properties. One is build, another one is rebuild, third one is deploy, and fourth one is process. So these 4 are very important. The build is the common option in any Visual Studio, any .NET projects or any Microsoft projects, which uses Visual Studio to build, to design. So build is to check the errors. If there are any syntax errors, then it will say there is any syntax error, go and correct it. Rebuild is already built project. If you want to rebuild, you can just try rebuild and rebuild, not going to do much difference. So let me try to build now. If I build it, you see here build started. And this is the configuration. This started to check the dimension. It's all good. Build complete, 0 errors and 1 warning. And you can see the warnings if you go here, maybe in the errors. What is that pane? You can see the warning here. The warning is dim customer, create hierarchies in non-parent child dimension. So it is suggesting me to create the hierarchies. You can ignore warnings. Warnings is always gives you some advice to improve the performance, but not the showstopper for sure. And it's saying one build succeeded, once a build one succeeded, and that means it looked for all the syntax errors and it certified that everything looks good and you can go ahead and deploy the project. So now how it looks when there is an error? How can I inject an error? If you see here, I created a dimension with I created dimension here, right? Customer dimension. Now let me go back to the cube, sorry, data source view, and this is a name query. I used what column I used, what attributes I created. Postal code is one of the attribute, right? So this dimension, this particular attribute postal code is referring to a column called postal code in the customer data, name query that we have created in the data source view. Now I'm editing this and I'm taking out this postal code. Click on OK. So this is a scenarios where you will build a cube and all of a sudden the source data, the data warehouse, people will go and modify a column or delete a column or add, adding new column is not going to hurt you, but deleting a column or something like that. If anything, any deletions or updations to the structure or schema of the tables that are used in your in creating the objects like dimensions and the cubes, then it's gonna cause trouble. Now let me try to rebuild it. Now it's saying one error. So if you see postal code, the key column refers to postal code and unknown column. So the error message is pretty clear here. So in the dimension customer table, which is this, there is a column reference to the postal code which is not available. So that is what the error meaning is. So you have to fix these kind of errors if you get anything. So you see it's getting highlighted in red underline. So either you have to delete this, delete this attribute to fix this issue, or bring the data to the attribute. So if you don't have that particular column in your source system, then in your data warehouse, then you have the only option that you left with you is to either delete the column, attribute, or give some hard-coded value blank as postal code or 12345 as postal code, some hard-coded value. Now let me go back and let me select this postal code and let me rebuild this, and it all succeeded. So I injected an error to show you how build fails if there are any syntax errors. This is a syntax error. I am using a column. I'm referring to a column in my data source view which is not available. Right now you see it's gone. The error message is gone. So this is about build. It generally checks for syntax errors. Now what is deploy? Before going to deploy, we need to discuss about one important property. When you say deploy, the English term, everyone can understand, oh, you are going to deploy the project somewhere. So where is that somewhere? Where it's going to get deployed? How will you know that? So there is a property, very important property under properties. If you right click on the project and if you go to properties, if you see the deployment page, you see the server where it has to deploy and what will be the name of the database once you deploy. So you can give something like SSAS training or wide, I hate this name, wide world importers. So this will be my database name. It's asking me what database name you want to give and what is the server where you want to deploy this project. Deploy means it will go and deploy the structure of the database, right? Whatever we are designing now, whatever we are defining, we created a dimension. This is a schema. This is the structure. This structure will be deployed to the server, whatever we specify here. I've given local host, or you can give any remote server in your network. If you know if that remote server has analysis services, and if it is running, then it will go and deploy that. Let's go back to our services just to quickly check whether the service is running or not. Go to SQL Server, Analysis Services. The service is stopped. This is the target server, Analysis Services, where we will be deploying. So let me try to deploy. and right click and select the option deploy. Wow, deploy started, but deploy failed. So if you see, the project could not be deployed to the local host server because of the following connectivity problems. So it failed to connect. There is a connectivity problem. So that is what it's saying. So um, I told you in the first session that you can do everything for the development. You can create dimensions, you can create cubes, you can create measure groups, you can create partitions, you can finish your development work. But to test it, to deploy it, you need that analysis services, the server with the analysis services running. So here I stopped it. So I could not, I'm not able to deploy the project. Let me start the service now. So I started my analysis services, and if you go and select deploy and deploy started, you can see at the bottom left where my mouse is, and it's deploying. And if you see, I asked it to deploy. Looks like it processed too. It read all the data too. So I just asked it to deploy, but it processed too. There is a reason for that. We will discuss about it. So this is deployed. Now this project is deployed to the server given in the server properties. Like, if you go here, whatever the server name that I've given here, there the project is deployed now with this particular database name. Let me quickly open SQL Server Management Studio to see whether it is deployed or not. So let me connect to analysis services through SQL Server Management Studio. This is database engine. I want to connect to the analysis services, and the instance is not tabular. So I connected, and wow, it's too slow. And the databases, you see, wide world importers database, which we deployed just now. I've given this name for the database, and under that there are no cubes. Only one dimension was created, and the dimension name is customer. So this is deploy. So this is, if you see, the build is to check for the syntax errors, and deploy is to deploy the structure of the project to the server. So now we have seen build and deploy. Let's go to the process. And before going to the process, why it processed when I said only to build, right? You remember it processed the database too. The reason is, if you go to the deployment, here you have to select do not process. The processing option you set to default, which means if you try to deploy, just go and process with the default option. So now it is saying no changes detected, and it just try to deploy. It's not processing. When I select the deploy option, if you see here, it's not processing. Now let me set it back. Properties. Set this to, let's say, full or default, and let me try to deploy. It's saying no changes. Wait. Let me change something. Where is that? I have category already added. Let me add value from. Now let me change the properties. Do not process. And when I try to deploy it, you see this guy only deployed now. This has not processed, even though there are changes. I made some changes to the structure, to the schema of the project. Still, it's not processing because I said not to process. Now, let me take out this from. Now, again, the schema is changed. Let me go back here. And I don't prefer to go for this default option. I always set it to do not process because I don't want it to process my cube if it detects any changes. If you see here, it's deploying and processing. So it deployed and processed. So the good practice is keep the property processing option to do not process. If you don't want to process after every deployment by default. Okay, and at least that's how I go with in my projects. Now let's discuss what is process. Processing means reading the data. Now the first step, if you see the build all the three options, the first one is really check for syntax errors of your project. Now the second one is deploy. It deploys the project structure into your analysis server, whatever the analysis server you specified. Now this analysis services will have only skeleton of your project. It says that okay, it requires these tables, and this table is used to create the dimension, that your table is used to create the cubes and so on, but the data will not be there. The data will come into the analysis services. This is your, let's say this is your relational, and this is your OLAP. So that to get the data from your relational to your analysis, we need to go for the option process. So if you don't process, if you just deploy your project, then it will be just a skeleton. You can't browse it, you can't see anything. It will say that go and process the cube, or to go and process it, then only you can see the data. So the processing means, in short, reading the data from your relational database or the database that is used in your data source connection here, okay, and read the data and place it into the objects in your analysis services. Now, let's process one dimension and see what kind of queries it will trigger and how the queries will be sent to the SQL server to get the data back, or any database for the matter of the fact. So now let me try to process the dimension. If I right click on the dimension, I will get this option, or on the cube I can do that. I have an option called process, or on the database or on the cube. If there is any cube created, then I can process it. Now, as only one dimension is created, let me process the dimension. If I right click and select process, it's giving me option what processing option you want to select. This is one of the important set of properties that you need to do if you want to get good command on analysis services. By default, the dimensions will be process full or process update. Okay, and we will discuss about each and every option in detail, one whole session dedicated for the processing options, but we have to go and finish a couple of other object creation before going to that step. Now I'll leave it as process update. If I run it, it will take each and every attribute and it will send a query to the SQL server, and it will read the distinct records and it will place it here. Now if you see, it's saying that bill to customer, 4 rows have been read, and if you expand it, it will give you the SQL query what it's always, the dimensions will try to get the distinct data. Okay, if you can go to the view details to get the query. I copied the query, and if I go to my SQL server, because my SQL server is the source for the cube, right? If I connect to my SQL server, and this is my database, go to new query, and now I copied the query, right? Let me paste it and execute it. It gives you those 4 distinct records. This query written by the analysis services engine is a generic query. This query should work if you're building the cube on SQL Server, and the way it generates the query will work on any database. If your for example, here the data source is SQL. Instead of SQL, if you point to Teradata, if your source is, if your underlying data warehouse is Teradata, then the query that it generates dynamically will be valid one, and if you execute the query in the Teradata database, it will return the result. So it always get the distinct records and it will store in the files. So now for every attribute you see as distinct query is sent. If you see it's saying that 404 records has been read for the particular attribute. Let me execute it, and you see 403, including all, I think it's 404 or 403. I've read it, I might have read it wrong. No, if you see, all these are the distinct values. It reads the distinct values and it stores in the form of a file, binary files. I'm going to show you how the data will be stored when the processing is going on. So among all the three, build, deploy, and process, process is very important. And if you process, it will automatically builds and checks if there are any syntax errors, and it will deploy and it processes. Or if you go for deploy, it builds and checks for syntax errors and deploy. And if you go for build, it just builds. You understand, right? So build means just build. Deploy means build plus deploy. Process means build, deploy, and process. That's how it is. Now, let me show you where the data will be stored and how the data will be stored. Generally in SQL Server, you know it's two-dimensional, and the data will be stored in the form of tables, which contains rows and columns. But here in analysis services, all the data will be stored in the files on the disk. Now, to see that, let me go to the C drive where I have my SQL Server analysis services installed. Program files, Microsoft SQL Server. I showed you MSAS, Microsoft Analysis Services. So if you want to go to the path directly, you have an option. Right click, go to the properties. Under general, you will have a data directory. This is the folder I'm trying to go there. So I can directly copy it and go to the folder, or go to SQL Server, MSAS, OLAP, and data. So if you see, all the data will be, whatever the data that is read will be stored here. If you see here, this is the project SSAS training. Oh, sorry, wide world importers is the database. And if you see, it has one data source file, and it has one DIN. And you see, this is your DSV XML. If you open that, it will have all the information about your data source, how many tables, what is the position of the table, and so on. Let me try to open. You see, this is how it looks. Everything in analysis services is an XML file. You see, this is a table. Preferred name, this is an attribute, I think. This is the employee. So everything is there. I mean, everything will be stored in the form of XML. Now, our key thing, let's go to the dimension. You see this AH store, AS store, analysis services store. I don't know AH store, and people don't go on up to this level. But I'm just showing you, just to give you an idea how the data will be stored. If you see, for every attribute there will be an all, and build to customer all. This is an attribute. LS store, OS store, SS store, S store, build to customer dot build to customer dot DS store. So these are all the different types of files that it will generate when you process it. And you can see the file size will be, the biggest one is the customer derived name. These are like 27 KB and 24 KB. And it will be increasing and decreasing depending on the data that is coming when you process it. Now, let me quickly do one thing. Where is our analysis services? I'll show you how these files will get impacted with your process. So now I'm going to this location, go for process. Yes. Yes. Okay, now it is giving me option to process. I'll move it to the right, and let me bring the folder. Okay. And on the left, instead of process update, I'm doing process clear. Okay. If I run it, what process clear will do is it will erase everything. It will erase all the files. Now if you see what I did, process, my bad, I did process full. Okay, if I run process clear, it will erase everything. Process clear is an option to clear all the data that is processed. Now if you see, the folder is completely erased, and it has only one file, that too XML document to give some information schema. So this is process clear. Now let me change the processing style, and let me try to process, let's say process full. Okay, and let me run it. And when it reads the data from your SQL Server, it stores the data in the form of binary files here. So this is how every attribute, particularly while processing the dimensions, every attribute, for every attribute, one query will be sent and the data will be read and stored in the form of binary file. Whenever you go to trainings, people say that data will be stored in the form of binary files, but no one knows. I mean, no one shows where the binary files are stored and how it is. So this is how. And if you see that just for 5 attributes, how many files are created. Like that, you can imagine for a huge queue with thousands of attributes and hundreds of dimensions and lots of calculations, how many files will be created, and it will create indexing files too if the data is too huge. We will look into that shortly. Now we discussed about build, rebuild, deploy, and process. We'll be discussing about the processing options later. That's as I mentioned, it's a separate topic. Now let's see what are the tabs that we have here. Let's say dimension structure is nothing but the structure of your dimension. It consists of 3 panes. One is attributes, and another one is hierarchy, and third one is data source view. Data source view is nothing but what table you have used from your data source view to build this dimension. It can be one table or it can be multiple tables. So you can use 2 to 3 tables also to create a dimension. For example, I can add one more table. Show all tables. And if I get relationships, then I can drag from here to here. So what it will do is it will build internally. It will join those two and then get the data. So that's a complex dimension or unwanted stuff for us. See, the better option is if you want to create a dimension using these 2 tables, you can join these 2 and create a named query in the data source view instead of having 2 tables here. If you have 2 tables here, that every query will be using the join and then get the distinct of the records. So we'll see that too. So show only use tables. Okay. Now, hierarchies are nothing but if the data is hierarchical in nature, like year, quarter, month, and what you call month, week, and days, and country, state, and city. This data we call it as hierarchical in nature. If the data, different levels of the data are one too many in nature, then we call the data in hierarchical format. If you have any columns or any attributes, let's say derived name or postal code to customer name or category is one too many, then you can create a hierarchy out of it. Creating a hierarchy is pretty easy. Drag it and drop it and drag the next level and drop the next level. So these are the 2 levels. By creating this hierarchy, I'm telling the server that one category will have one or many customers. So it will be one too many to this relationship, right? So the customer will roll up and give me the category information. So there may be 10 customers. 10 customers will form one category. Similarly, 30 customers will form another category. It's one to many relationship. So whenever you define a hierarchy, user defined hierarchy, we call this as, because user, we are defining those hierarchies. These are not natural. So if you see here, when you define a hierarchy with 3 levels, we call each attribute drag here as a level. So then the data is expected to be like this. The first one will have 1, 2, or n number of members, and each member will have children, and each member will have children again. So this is the third level. This is the first level, second level, and third level. So this data we call it is in hierarchical, and if you have data like that, then it's always good practice to define hierarchies. Now, for example, category to customer, I created a hierarchy, and I can have postal code. Though the data is not hierarchical in nature, I'm just creating to show how easy it is to create a hierarchy. But always remember, while creating a hierarchy, try to make sure the first one, the topmost level, is one to many to the next level, and which is one to many to the next level, and so on. So this is how we create the hierarchies. So the dimension structure of any dimension will have the attributes, the hierarchies, and the tables that are used for this for creating this dimension. Now if I click on process, this is also a process option. You see the circle. It's saying that the server schema, whatever we have, the project structure, whatever we have, is changed compared to the one that is in the server. So it is asking me whether you want to deploy it or not. I said go on deploy, and it's giving me the window to process, and the process is succeeded. Now let's go to the fourth tab. So we process the data, we read the data from our relational database, and we placed it in our analysis services. Now, how to see the data? Browser is an option that is provided in Visual Studio for validating or for seeing what kind of data has been read into the each attribute and hierarchy levels in the dimension. Now, if you see, this is the hierarchy that I have created. The name of the hierarchy itself is hierarchy. I can change the name, but I have given it as hierarchy. You see here. Now, if I go here, this is hierarchy, and it's saying the default one will be all on top. It has two, what is the first level for us? Two categories, NA and novelty shop. Under this category, we have these customers. Under this category, we have unknown customers. Under that, there is only one postal code that is not applicable. Under this guy, this is his postal code. This is his postal code. This is almost one-to-one, right? So every guy will have his postal code. Or we can do one thing. We can push the postal code to top and customer to the bottom. So one category will have 10 postal codes, and each postal code may have one or two customers. So I changed it. I altered the order of the hierarchy, and let me quickly process it, which means I am reading the data fresh based on the new structure. Now let me go to the browser, and this button is to reconnect, or if you see the dimension has been reprocessed on the server. To prevent possible browsing errors, click reconnect. If you reconnect, it will give you, see, if you see here under novelty shop, we have these postal codes, and this postal code there are two customers, Wingtip Toys, Jamison, IA, and Texas. Similarly, it's a one-to-many, right? So this is the hierarchy. This is how you create the hierarchies. And this particular pane, the browser page, is mainly to view the data. View the data that is coming into your hierarchies, and also attributes. Build to customer. If you expand, it will give you what are all the different build to customers you have. Buying group. It read these three distinct values. Derived name. My name is so and so. This is what we created, right? And similarly, postal code. It will give you all the postal codes. So this is where you can see the data. So now let's go to the next tab here, translations. Translations is one of the useful options when I start a career on SSAS. So people from different countries, they want to see the data, they want to use the cube. If my cube or the cube that I created is used in many countries, then people want to have their own names, right? Names in their own language. For example, the translations are used to create multilingual project, multilingual dimension, right? Now, how to create a translation? If you see here, new translation, if you click here, it will ask you to select what country, or for what language you want to create a translation. So this acts as a translation to the other languages. Like for example, let me pick some language which I'm aware of. Let me go to Telugu. I'm creating a translation for this. So I don't know what we call customers or how to write it in this particular language, but we can get that from either the users. Let's say if I have set of users who want the cube and everything in Telugu, then I have to send them, okay, these are the list of dimensions and attributes that will be available as part of the cube. You give me your language. I mean, you give me the names or how you call it in your language. We can place it in the cube so that it will be easy for you. Based on your system language settings, it will be automatically showing in your mother tongue. So, for example, so let's say for example, customer. I don't know how to get there, but let me go to Google Translate and enter the text to customer. I want to see it in, let's say, Telugu, if it is there. It is not here, so let me pick some language which, oh, we have Tamil. This is not bad. So this is what we call customer in Tamil. So what I can do is I can copy it and paste it. Generally, users used to give that information. Users will give that information. But here, I'm just showing to show you an example. I'm typing it in Google Translate and getting that information. Now, customer key, what people call for customer key. Not bad, you're getting terms. I mean, at least a person who knows Tamil can read it and understand it. And this, I hope that you will not get anything for this. You are getting it. So like this, if users give you the set of translations, what they want, what they call for an attribute name or what you call the dimension name and so on. See, this is customer and this is again customer. So let me copy it from here and build to customer. Let me quickly check. So I created translations. Now I created few translations here, right? And let me save it. Let me deploy it. Actually, I just need to deploy if there are any changes in the translations. But processing is not a harm here. It's just half a minute or half a second process, right? Now let's see how it looks to the end user who selected Telugu as their language. Okay. If you go to the browser, you can test it by using the option here, language. So what it says is you can test the translations by selecting the language. So the translations that we created is for Telugu India. If I select this, you see the names are coming in Tamil, right? This is what we have created. So it will be easy for the guys to understand. So this is the use of translations. It translates the terms, the attribute ID, the dimension name or cube name or your measures name, everything into the language that they are interested to see. But do you know what the problem is? You can see only the attributes in this name. Like for example, if I have data and I created a translation for the language Telugu, they can see the attribute names, they can see the dimension names in Telugu, but not the data. The data will remain the same. Let's say, for example, here I see this in Tamil, but if I expand the data will remain the same. Similarly, I think this is for customer. It gives you the customer name in the same English. You cannot translate the data completely. So the use of translations is very limited, and it is just to see or to understand the each attribute name or what is that measure name and what is the cube name, like for people in countries where they go with their language as the most important and they don't want to learn English in particular. Now let's see the last tab here, the attribute relationships. The attribute relationships is key in improving the performance of your attribute processing as well as querying. Now, if I see, if you remember, we created an hierarchy and there is a warning sign saying that the attribute relationships do not exist. It's giving you an advice. Go and set the attribute relationship so that the performance will be even better. Now, category, postal code, and customer. This is the hierarchy I have given. And all these three came out of it. So this is the parent, the key. The primary key is the root. So everything will be under the primary key. Now, if we define a hierarchy, this got separated. And here, if you can define the relationships properly, then it improves the performance of, of your queue processing as well as querying in particular. Querying is very important. Now, how to give the relationships? Postal code is directly related to customer key, but it came out. And similarly, category, similarly, customer. If you see the hierarchy, it always flows from bottom to up. What it says is customer will roll up to postal code and postal code will roll up to category. That's what it is saying. Now, how to define that? The customer will roll up. So drag this and drop on that to postal code, and the arrow mark should be on the to which it is going to roll up, and postal code will roll up to category. So now we define the attribute relationships of the levels that we have in the hierarchy. So it should always flow from bottom to top. The topmost one will be here, which means this is the highest roll up, and you see the arrow mark pointer here. Similarly, the next level is postal code, and the first level of the bottom level is customer. So the bottom level to the next level you have to drag and drop. From next level to the top level you have to drag and drop. Now if you go back here, you see the warning sign is gone. Now let me quickly process. Okay, the cube is processed. The same, everything will remain the same in the browser except a slight performance improvement if you are dealing with huge data like millions of records in your fact table, and this dimension is going to join with that. In that case, it's going to give you performance gain. So with this, if you use this category in your queries, okay, it won't go to customer key to get all the category information. I'll show you an example here. This is very important. The key column here and this hierarchy. If you go to the paint, so this is your different levels. Okay, this is your key, and this is your fact data, set of fact data. Fact data means like sales. So let's say this is year, this is semester, this is quarter, this is month. Okay. While processing, what it will do is it will have a join to the key, and then it will read all the data, and it will store the data by month. So the month-wise data will be stored by going at the root level, that is at the key level, and by reading all the fact data. If the fact data has 50 million records, it read all the 50 million records and it create aggregations, and it store the 12-month data. It retrieves that and it stores that 12-month data, and each month what is the sales. Okay. Now if you go for quarter, and if you define the attribute hierarchies properly, then it won't repeat the same job of going here and read all the 50 million records to get this table of 4 records, 4 quarters per year, right? So to get that, it won't go this path. Instead, what it will do is it will take the month, these 12 records, and it will create the 4 quarters out of it. So instead of going to 50 million records, it reads the data from the month's data, which will be maximum of 12 months in a year. So this is happening because you are telling the server by creating the attribute relationships that these months will be rolled up to the quarters, and these quarters will be rolled up to the semesters. So for semester data, it won't go. through all the records. It takes the quarters and it sum up and it returns the data. It will be faster. Instead of going through 50 million records, if it can go through 4 records to get the semester data, it will be super fast. And for a year, these two will roll up and give you the year information. It won't need to go here to calculate it. So that is the advantage of defining attribute relationships for the hierarchies that you have created. If you define the attribute relationships properly, then the query performance will be improved when you're seeing the data using the levels of the hierarchy. Levels of the hierarchy is nothing but category is one level, postal code is one level, and customer is one level of this hierarchy with the name hierarchy. And here, if you ask me how to identify whether what attributes will form a hierarchy and so on, so that you have to do as part of your requirement analysis or as part of your analysis about the source data. I spend a lot of time in understanding what is coming from source and how the data is. How the data, whether it's a hierarchical or if it is hierarchical, what columns are hierarchical in nature. So you have to spend considerable amount of time in understanding the data warehouse. So that will make your work easy while defining your cube. So this is about the different options we have or different tabs we have in creating the dimensions. The next key thing is the properties. And the most important property that you have to know is the key column and the name column properties of the attributes, and and if you see here, for example, if you go to the customer key column is available but name column is blank. And what is this key column, what is name column, and what is value column? And we see a couple of other important properties like hierarchy enable and hierarchy visible. So in next session we'll be discussing about the complete properties set. Not complete, there are few properties that we can discuss now and few properties we have to revisit after we create our first cube. So once you create your cube, then only it makes sense to you to go and look into few properties here. So we'll try to cover properties and we'll try to start creating our first cube in next session. Thank you guys for joining today.